Hi everyone, welcome to Differential Calculus. Today we explore lesson 3.4, the chain rule. Number one, the idea. Let's take a look at the derivative with respect to x of 2x minus 1 square. We can do this by FOIL out 2x minus 1 square. That gives us 4x squared minus 4x plus 1. And then from there, we have 4 times 2x minus 4 plus 0, which is 4, 2x minus 1. And we can break it down a little bit further into 2 times 2 of 2x minus 1. The reason why I break it down this way is because from here, we can see that this does look like derivative of the outer function. And then the number 2 here is the derivative of 2x minus 1. We're gonna move this 2 right here. Derivative of inner function. Pretty cool, huh? Okay. Yeah, what this boils down is we can do the derivative this way. Derivative of 2x minus 1 square is, well, a function in terms of x to the power 2. We can use the power rule. So 2 times 2 x minus 1 multiply to the derivative of the inner function 2x minus 1, and ta-da, 2 times 2x minus 1 times 2. Yay! Here come another example. Derivative of e to the 2x. So e to the 2x is ex times ex. Most of you know that 2x is x plus x. So using exponential rule, it is the same as ex. We use the product rule here. Ex times derivative of ex plus ex times derivative of e to the x. So we have a ex plus ex 2 ex, which is 2e to the 2x. And I can rearrange this as e 2x times 2. Well, notice that e to the 2x is derivative of outer function. That is the derivative of e to a function in terms of x. And 2 is the derivative of the inner function. That is the derivative of 2x. Here come another way to look at this derivative. D over dx of e to the 2x is, well, derivative of the outer function e to the 2x multiplied to the derivative of the inner function derivative of 2x which is e to the 2x times 2. Wow. What we see up here through these two examples, the process of doing this kind of derivative in which one function is inside another function is called the chain rule. So the basic of the chain rule is derivative with respect to x of f of gx is f prime of gx multiplied to g prime x, derivative of the outer function multiplied to derivative of the inner function. First example, we have derivative with respect to x of a function gx to some power n. This is n times gx to the n minus 1 multiplied to g prime x. In the second example, we have derivative with respect to x of e to the gx. This would be derivative of the outer function e to the gx multiplied to the derivative of the inner function g prime x. Just two special cases of the chain rule. Let's apply the chain rule and do some example. Number 3 example, find f prime x. First example, fx equal e to the psi x. F prime x here is derivative of the outer function. Psi x is g, so e to the psi x multiplied to the derivative of psi x, e to the psi x times cosine x. Yay! In the second example, fx equal to x squared over square root of x to the 3 minus 1. This can be written as x squared over x to the 3 minus 1 to the power 1 of 2. This is the quotient. We got to use the quotient rule. F prime x is low d high x3 minus 1 to the power 1 of 2 multiplied to the derivative of x squared minus high d low x squared multiplied to the derivative of x to the 3 minus 1 to the power 1 of 2 over low square x to the 3 minus 1 to the power 1 of 2 square. So we have root of x to the 3 minus 1 multiplied to 2x minus x squared multiplied to, well, we have a function in terms of x to the power 1 of 2. So apply the chain rule. 1 over 2 root of x to the 3 minus 1 and multiply to the derivative of the inner function, which is the derivative of x to the 3 minus 1, 3x squared over x to the 3 minus 1. And then from here, we can simplify this. A little bit. So what we have is the 2x root of x to the 3 minus 1 minus 3x to the 4 over 2 root x to the 3 minus 1, everything over x to the 3 minus 1. I'm gonna simplify this complex expression by multiply to the LCD. The LCD 2 root of x to the 3 minus 1 over 2 root of x to the 3 minus 1. And this gives us 4x times x to the 3 minus 1 minus 3x to the 4th over 2. So we have 1 plus 1 over 2, x to the 3 minus 1, 3 over 2. Distribute and simplify. So 4x to the 4 minus 3x to the 4 is x to the 4 minus 4x over 2 x to the 3 minus 1, 3 over 2. Now, that is the simplest that it can get. Let's take a look at another example. In this one, we're going to have to figure out the equation of the tangent line to the curve fx equal to cosine square x minus sine square x over sine x cosine x at x equal pi over 4. To do this problem, first thing is simplify. Fx is cosine square x minus sine square x over sine x cosine x. Cosine square minus sine square is cosine 2x over sine x. Cosine x is the half of sine 2x. Yeah. And then from here we say that we have a 2 cosine over sine is cotangent of 2x. F prime x is 2 times the derivative of cotangent 2x. So we find the derivative using the chain rule. So 2 multiplied to the derivative of the outer function. Derivative of cotangent is negative cosecant square. Then multiply to the derivative of the inner function, derivative of 2x. And this gives us minus 2 cosecant square 2x times 2, which is minus 4 cosecant square of 2x. Slope of the tangent line is m equal to f prime of pi over 4 equal to negative 4 cosecant square 2 times pi over 4. Negative 4 cosecant square of pi over 2 minus 4 over, well, cosecant square is 1 over sine square, so sine square of pi over 2, which is negative 4 over sine pi over 2 is 1, so 1 square, negative 4. And we also have y sub 1, that is f of pi over 4. We use the simplified function 2 cotangent of 2 times pi over 4 equal to 2 cotangent of pi over 2. Cotangent is cosine of sine, so 2 times cosine of pi over 2 over sine of pi over 2. 2 times 0 over 1, which is 0. Now the equation of the tangent line. Y minus y1 is mx minus x1. Y minus 0 equal to negative 4 x minus pi over 4. And so y is equal to negative 4x plus pi. Got it. Thank you for watching. I hope you found the content useful. See you in the next video.